to do the fresh share calculation. Fresh share calculation to design the FASU. So you can see here, this is the fresh share calculation sheet. So what we will do, simply erase this. Actually the formula is you can see here, CFM for fresh share calculation, CFM per person into number of people plus CFM per square feet into area square feet. If you see, if you open this app software, let me open this app software and cancel, simply cancel this, and cancel also this one. Go to the space, open this once again, cancel this, cancel also this one, and open the space. Okay, you can see here this is the outdoor ventilation requirement. If you select here office space, simply select this office space, then you will see here the outdoor air requirement CFM per person 5 and CFM per square feet is 0.06. Okay, same formula we are going to use here to calculate the fresh air. You see, CFM per square feet 0.1 and number of people and CFM per person is here. So the formula is CFM per person, CFM per square feet into area in square feet, and then here is CFM per person into number of people. Okay, so what I am going to do here, simply ground floor a space name. A space name is I am copying from here. Okay, simply I am copying from here, paste it here. Okay, copy one by one. Lobby ground floor area 31. Simply place the area here 31. Area in square feet and here a square meter. 1 square meter is equal to 10.76 square feet. What you will do, simply select this one and multiply into 10.76. So this is in a square feet. Okay, so what you will do, simply copy these formulas to here. Okay, and here is also, next is first floor, first floor, office 1 2 3 4 5 6, then corridor, office 1, office 2, office 1, office 2, office 3, office 4, office 5, office 6, and corridor, first floor. Okay, then simply paste here this, copy this one, copy this area, paste it here. Okay, so this is your area and this is in a square feet. And simply for the lobby is nothing but the office. So for the office, you see here, Simply select the office space here. Office space, where is the office? Is the office. So area 0.06 CFM per, and area CFM per person is 5 and CFM per square feet 0.06. So CFM per square feet is here 0.06. 0.06. All will be same because all is office space. So to here for 0.12 for corridor, and number of people is lobby. Sometime lobby, how many people are there? So number of people is 0 in the, if you see here, this is the lobby space. In lobby space, maybe the people are there, so you have to assume the number of people, or you have to use the S-ray chart to calculate the number of people. Okay, so what you will do, assuming the number of people is 10 for this lobby. So assuming here 10 number of people, and CFM per person is 5. Okay, and for the office is generally 2 people only. So CFM per person is 5. 2 people in one office. Corridor, number of people is 0. CFM per person is 5. Okay, so this is your fresh air. Click here, it's showing the formulas. This is your fresh air. This is your fresh air. Okay, the first floor. Similarly, you have to calculate for the second floor, third floor, fourth floor, fifth floor, all the floors. Okay, so what we will do, simply copy this one because the typical, so simply paste it here. Or what you will do, simply write like this: first floor to fourth floor. Okay, the same. First floor to fourth floor is the same. Fifth floor is different. First floor to fourth floor, and here is the fifth floor. Fifth floor is which type of space are there? Office only. So office space, also this one, office, and area is 91 square meter. I think 91 square meter. So area in square feet is this one, and 0.06 CFM per person. 0.06 CFM per person. Number of people is 2. CFM per square feet is we copy this one, paste it here just to copy the formulas. Okay, so here you can see what is this. Okay, this all formulas under. So what you will do, simply copy this one, paste it here. Okay, now copy is nothing but we are copying the formulas only. Okay, so simply copy, paste, also paste. Okay, so copy is nothing but we are not going to copy the any number or something. We are going to copy the formulas. You will see here H11. So this is the H and this is the 11. H is nothing but the H11 into G11. So this is the H11. Okay, and G11. That means CFM per person into number of people plus F11 E11. This is the F11 CFM per square feet into E11. So this is the E11 column row. This is this shell. This is called shell where this column and row are coincide. This is called shell. So E11 shell into F11. So F11 is nothing but CFM per square feet into area square feet plus CFM per percent number of people. So this is a formula already applied here. Okay. So these are the fresh air for each floor. So total is here. You should add all the total to select the FAQ. So what I am going to do here I am going to do the sum. Okay, here is the total fresh air requirement 476 CFM. Okay, these are the total fresh air requirement. What is the next? So next will be your FAQ selection. So I am going to design for the Dubai. Okay, Dubai. So outside here is, if you open this app software, simply cancel this one, go to the weather, simply select this, and if you see here, this is the summer driver. No, you have to go to the weather properties, open the weather property, and simply select here region Middle East, location is UAE, and I'm going to design for the Dubai. So for Dubai you can see the summer dry bulb is 107 degree Fahrenheit. So here is 107, and outside weight bulb inside weight bulb is 75 degree Fahrenheit. So here is 75. Okay, so what I'm going to do, I'm going to select one FAQ. So FAQ total airflow for the FAQ, that means fresh air flow. Here is the fresh air flow 476. So 476 is the fresh air, and dry bulb temperature is 107. Wet bulb temperature is 75, and here is this is the on coil actually. This is the entering air temperature, and this is the leaving air temperature. So leaving air temperature is nothing but the comfort temperature. So 76 and 50% RH. Okay, so using these two values, you are going to select these two. Okay, so simply open this psychrometric climatic data, or simply open this psychometric chart and plot this use these two value and plot the point. Okay, so how to use this psychometric chart, I have already made the video on that, so please go and watch that video how to plot. So I'm going to plot this. Simply select this at the point. I'm going to select here dry bulb temperature 107 and wet bulb temperature is 75. So once you put this 2 point, you will get the value here. RH is 21 and humidity ratio, this is nothing but W is humidity ratio, so 21 and 75. So what I am going to do here, RH is 21, humidity ratio is nothing but 75. Okay, and next one is off coil temperature. So off coil temperature 76 dry bulb, and the percentage humidity is 50%. So again select this one, 76 trival temperature, and now you select here RH. RH is 50%. You will get the wet bulb 63 and humidity ratio is 67. So here is 63 and 67. Okay, so this is your sensible heat and latent heat. This is the total heat. So how to calculate the sensible heat? Sensible heat is nothing but, if you see here, close this first psychometric. Don't want to save. Okay, if you see here, this is the sensible heat formulas. Sensible heat is nothing but the 1.08 into CFM into delta T, and latent heat 0.68 CFM into delta T. So what I did here, sensible heat in BTU per hour, 1.08 into B10. B10 is nothing but this one, B10 CFM into delta T. Delta T is nothing but the dry bulb temperature. Okay, for sensible heat we are going to use the dry bulb temperature. It is nothing but the outside temperature, outside dry bulb temperature minus inside dry bulb temperature. So 107 minus 76. Then I got this 15936 BTU per hour, and is converted into the tonnage. So divided by 12,000. And similarly, I have calculated the latent heat here. Click here, the 0.68 into B10. B10 is nothing but the CFM 476 into delta T is nothing but the humidity ratio, temperature difference between humidity temperature ratio difference. Okay, so 75 the wet bulb minus of coil temperature 67. So this is the delta T. I get latent heat 25,518. This is the total heat. So I added and divided by, so 1.510 is nothing but the 2 ton. So 2 ton if fresh air FAHU required 2 ton FAHU. So this is the schedule. So now we have to update this also. FAHU G plus ground floor plus G+5 building, and number is 1, and cooling capacity is 2 ton. Sensible cooling, if you check here, the sensible load is 1.3. Simply enter here 1.3, and fresh air CFM is total CFM 476, and entering air temperature is 107, dry valve, wet valve is 75, and leaving air temperature is 76, and wet bulb temperature is 63. Okay, and ESP will be calculated after the ducting. So this is the schedule. So we have calculated the FAHU. Now what we will do, simply place the FAHU machine, decide where you want to place the FAHU. Okay, so we are going to place FAHU on the ground floor. Okay, or we are going to place it on the terrace here, second floor or ground floor. So for example, create one layer for FAHU. FAHU, or simply copy this FAHU. If you see here, the FAHU already is here. Only but I am going to create one FAHU. Simply create one layer. Is EC VRF FAHU. I'm going to use a blue color. Double click to make in current layer, and I'm going to place the FAHU here. This is two ton only, so we can place it here also in the toilet, not in the toilet. We can place it here also on the wall, or we can place it here in the AC room also, and provide the fresh lowers to get the fresh air. So I'm going to place it here. This is your FAHU. This is FAHU 2 tier. FAHU 2 tier. 2 tier. Okay, so this is 2 tier FAHU. Okay, now what we will do, simply do the ducting for this FAHU. I'm using the polyline. Okay, so I'm using the polyline TL, and here is the width. You have to take now 50. Okay, the width is 50 mm, so I'm going to use this FAHU. Okay, so what I'm going to do, I'm simply going to give branch for the fresh air duct in each office. Okay, okay, here, and this is the fresh air for this one, and is here. So this is the fresh air I am going to provide in each branch, each corridor, and for the corridor here, each office. So this is the fresh air. So now what I'm going to do, simply select this. I'm going to change the color is blue, and now I'm going to match this one. Just match this, match. So the elevation is actually going to be different for this refrigerant piping as well as the fresh air FAHU. So elevation will be different. So this is your fresh air ducting. So now I'm going to use the special spline SPL. Is to connect the ducting with indoor units. Flexible duct. This is actually flexible duct. Only we will connect the cassette unit. Okay, and for the corridor already here. This one already I leave this duct here. Okay, image properties. So these are the fresh air ducting layouts. So simply copy this one. Copy to each floor. Okay. So second floor, third floor, and fourth floor. This sizing will be done with using apps and this duct sizer. You have to consider the airflow. You will do the sizing. Okay. So sizing, how to do the sizing? I already made the video duct sizing. So you go and watch that video. This FHU 210 and total airflow is 476. 476 CFM. Total CFM. Okay. So each floor, how much is the CFM? No, this is actually wrong. Actually, this is for the first floor. This is 476 for the one floor. 337 into 4. 337 into 4. 1348 plus ground floor 70 plus 69 is the fifth floor. So total CFM is 1487. Here will be 1487. 1487. Okay, this is for the total floor, complete floor. It will be over 1487. Accordingly, everything will be changed. 1487. So total 510 is here. Here is 4.1 total is 5 tier FHU, and here is 4.1 tier, and total fresh air is 1487. 1487. Okay, so accordingly you have to select FHU and do the duct size. Let's see, the 5 tier 1487, 5 tier FHU, 5 tier FHU. Okay, so we have already done the connection all, so we will do the pipe sizing, refrigerant pipe sizing. So the next is pipe sizing. So how to do the pipe sizing? We will use this chart. If you see this, how to use this chart, manual piping chart for VRF VRV. So this is the capacity index, this is the tonnage. So we will see the tonnage first. For example, this is a 2 ton. Okay, 2 ton split AC. So what will be this pipe size? So for 2 ton you have to check the capacity index. So 2 ton 64. So 0 to 66 capacity index pipe size will be this one, and 63 to 140 pipe size will be 9.5 to 15.9. From this chart, this is the capacity index. The capacity index will be selected from the tonnage, and after the capacity index selected, you have to select the pipe size. So for 2 ton, this will be your pipe size. This is the gas pipe and this is the liquid pipe. Okay, sorry, this is mistake, by mistake is wrong. So this is your liquid pipe and this is the gas pipe. Gas pipe is always bigger. Let me change this. We'll change this one. Actually this is a manual piping chart. In this is liquid, this is liquid, this is liquid, and this is gas. Okay, because gas pipe is always bigger in dia, because of volume is increased, so dia is increased. Okay, so this is by mistake, this is by mistake only, so we have to shuffle this. This is liquid and this is the gas. Okay, this is liquid pipe and this is the gas pipe. Okay, so now what I will do, I'm going to print this and print. Okay, so in the desktop, manual VRV piping chart. Okay, I will replace this. Okay, close this one. Now open this. Okay, so you can see here, this is a 2 ton machine, 64 capacity index. So 0 to 62, this will be the pipe size, and after 62, 63 to 140, the liquid 9.5 and gas is 5.9. So what we will do here, 5.9 and 15.9. So here we have to write, simply select this one, write here text. So this is your 9.5, 15.9, 9.5. Actually, how to bring this dia symbol I will show you. So the shortcut is %C. If you type like this, then it automatically convert this dia symbol. Okay, so after converting this dia symbol, you have to write 9.5 slash 15.9. So 9.5 slash 15.9, 15.9. Okay, this is the pipe size for this two. This actually showing only one, but there are two pipe, one is liquid and one is gas. So this is your pipe size. Simply use ellipse command here to show this. Okay, use one line command, type L, place it here, refrigerant pipe size. Okay, so this is your pipe size. Okay, now the next is here. Here is 2 ton. Okay, so it will be same. So what we will do, simply copy this one, copy this, place it here, or place it here. Okay, so move this one here. Okay, so for this one, this is the pipe size, and here is what will be the pipe size here. So what I'm going to do here, I'm going to use the same. Just copy this, go down here, simply rotate this text. Okay, here what will be the pipe size? So here will be the same, I think. Here is same because this is 2-ton machine. So I'm going to use the same pipe size here, paste it here. Okay, so what will be the pipe size here? So if you see here, this 2-ton machine and this is the 2-ton, so total will be the 4-ton. Then what will be the capacity index? You have to check the capacity index. So if you see here, this is the 4-ton 84. So the pipe size will be the same, 63 to 140. It will be the same. Okay, and here what will be your pipe size here? Here if you see here, this how much ton? 2-ton. So total is 6-ton. So for the 6-ton machine, this is the 5, maximum is 5, 6-ton 200. So 141 to 200, pipe size is going to be changed 9.5 to 19.1. 9.5 to 19.1. 9.5 to 19.1. First one is liquid pipe, second one is gas pipe. So 19.1. Okay, and next one is here. Next one is this one. So for this one, if you check this, here is the total 6-ton and plus this one, how much ton? 3-ton. The total is 9-ton. So from this chart, you have to calculate, this is the maximum is 8-ton. So you have to add this capacity index 8-ton plus 1-ton for this capacity index. So total will be 250 plus 32, 282. So 280 to 300 to 200 to 300, 9.5 to 22.2. 9.5 to 22.2. 22.2. Your pipe says here, and for this one, 3-ton to 3-ton, what will be the capacity index? 3-ton, 4-ton, 84. This is the same, 9.5 to 5.9, 15.9. So simply copy this text. Okay, and place it here. Okay, and also here, this is also 4-ton, same. Okay, and this is a 5-ton. So for the 5-ton, we will check this. The 5-ton 125, so 140, it will be same. 5-ton also same. It is same, all same. Okay, so here will be your how much tonnage. If you see here, this is your 3-ton. Okay, and here is 2-ton, 2-ton, and 2-ton. So total is 6 plus 3, 9-ton. So 9-ton, for 9-ton, how much will be the capacity index? 282. So 282 is comes under this index. So 9.5 22.2. 9.5 22.2. Okay, and here what will be pipe size here? Okay, 9-ton plus this how much ton? 4-ton. 13-ton. So 13-ton, what will be the capacity index? 13-ton is not here, so if you see here 8 plus 5, 13. So add these two capacity index. 250 plus 125. 375 comes under this. So 12.5, 28.8. 12.5, 28.8. Here is the pipe size. Okay, and here what will be the pipe size? So total capacity index here is 13 ton plus 5, 5, and here is 5. So 13 plus 15, how much? 13 plus 15, 28 ton. So 28 ton, what will be the capacity index? Or simply what you will do here, the pipe size given from outdoor to first draft net. So what you will do, this is the outdoor and this is the first draft net. So what will be the pipe size? So go to this thumb rule or first floor. Total tonnage is 28 ton. Convert into HP. So the tonnage into 1.25 is the conversion of HP. So we have to convert. Here is 28, sum of this. If you want to add, simply check this one how much tonnage. So sum of the one floor, this is the first floor. Okay, and this is the sum. So to convert this into HP, simply multiply into 1.25. Okay, so 34 HP, 35 HP is the machine size. 35 HP. So from this chart you will select this 18 to 25 HP. This is the pipe size. So what you will do, this is the maximum 18 to 25. So use this one, 15.9 to 28.6. 15.9 to 28.6. Or you have to check the catalog manual. If you check this manual, this is from the VRF. Check this. This is the VRF manual. You will select, check here. Here, let me here. Let me rotate this. Okay, here. You see here, this is the outdoor capacity in HP. This is actually manual for VRV manual, VRV AC. So if you see this, our capacity is 35 HP. So from this one, 36 HP. Maximum is 36 HP, 38 to 48. Our is 34, so we have to use this pipe size. Gas pipe is 41.3 and liquid is 19.1. So here will be from outdoor to first draft net. This pipe size will be from this manual 19.1 liquid and 41.3 gas. 19.1, 19.1, 41.3. 41.3 is the gas pipe and 19.1 is the liquid pipe. So this is the piping. Okay, and how to give this name of this rough net. This also there is chart. If you see here, branch kit less than capacity index less than 200. So the branch kit name is 22 TP, 200 to 332 TP. Same thing you use. For example, if you see here, how much is the capacity index here? You have to write here capacity index. So for example, this 2 ton, total is 4 ton. So 4 ton, what will be the capacity index here? 84. less than 200, so this roughness is 2t. This is 2t. It's 22t. Okay. Similarly, you have to do the pipe sizing for also. What you will do, copy this one. First floor outdoor unit 34 HP. 34 HP का horse power है. This is machine is for 34 HP. First floor outdoor unit. Now what you will do, similarly I have to copy this all sizing. Okay, I'm going to copy this all and copy from here, copy from this point. Okay, and paste in each floor because it's same, because one unit is serving to separate unit is going to serve for each floor. I have divided into the zone. Okay, this one more little bit up. Okay, so pipe sizing is also done. So next is this one, this side. So pipe sizing is also done for all, and here your pipe size will be this one. This is 3 ton 3 ton each. I'm going to copy this, and here pipe size will be 3 ton. How much is the capacity index? So 3 ton, 2 ton, 4 ton. So 2 and 3, 64 plus 32. 64 plus 32, 9060 here. So 9060 here comes under this. So 9.5, 15.9. 9.5, 15.9. 10.9. Okay, this one also same. I'm going to copy this. Move. Okay. So I think you learn how to do the pipe sizing. So we have done the pipe sizing as well. Now the next is we have to show all this here in the riser diagram. This sheet is actually we have to place here, and this is sheet is for the selection only. So you can use the selection. You can use the selection with software, or you can use with manual selection with catalog. What you will do, simply I'm going to erase this, and this is the zone. So zone 1 is your first floor. Zone 2 is second floor, third floor, fourth floor. And ground floor is nothing but the split AC. So, and this is the area. So how much is the area? So the total area is, you can check the area here. 398 square meter. So total area will be 398 square feet. Even here in the square feet, check the area in square feet, how much it is. Square meter 398. So simply convert this to 398 square meter into 10.76. 4282 square feet. Okay, and the same is for each floor. Okay, and what will be your fresh air for each floor? Each floor fresh air CFM is, you can check it from here. Actually this is spaces for each spaces. Okay, so first floor, office 1, office 1, office 2, office 2, office 3, office 4, office 4, office 5, office 5, office 6, then corridor. Okay, and 4, 5, 6, 7, still it. Okay, so what we'll do, this is for the first floor summary. You have to prepare the summary as well. First floor summary, you have to prepare this summary. This is for this sheet is for selection only with the catalog selection. So office 1, what will be the area in square feet? 50 square meter. We'll see here for office 1. See the area in square meter is square feet. So these are the area in square feet. I'm going to select this, copy this. I'm going to paste it here, paste space here. I'm going to paste space cell, paste value. Okay, as you can see in here. Okay, so office 1 538, if you see here, it's 538 450 727. So this is these are the area in square feet. Okay, so demodified CFM also you have to copy from here, pressure calculation sheet, dehumidified air. Copy this one, paste space cell, paste value. Okay, these are your dehumidified air. Delete this one. Okay, so these are dehumidified air and this is the fresh air. So first put this one tonnage. So first office 1, what will be the tonnage? If you check this load calculation, office 1 4 ton, 3 ton, office 2 3 ton, then 5 ton up to 6. 4 ton, 3 ton, then 5 ton each. Here is 4 ton. 4 410, 310, then 510. Office 4 is 510, also office 6 is 510, office 6 510, then corridor is 210. 210. Okay, to convert this into the kilowatt, so 110 is equal to 3.51 kilowatt. What I am going to do, simply erase this, convert this, simply apply the formula. 10 is equal to 3.51 kilowatt, so multiply into 3.5. So this is the, simply I am going to copy the formula. Okay, this is the tonnage in kilowatt and this is in TR. What will be the fresh air CFM? So for fresh air CFM, simply copy this, the fresh air CFM. I'm going to copy and going to paste special here, paste value. These are your fresh air CFM. So based on this, you have to select the equipment. This is the summary of heat load. This is heat load summary. The heat load summary. Okay, and these are the selection. Based on this heat load, you are going to select the machine. So for example, indoor unit, selected indoor unit. The required is calculated is 410. I am going to select, for example, here 4.5, for example. Okay, and here is 3.5. How to select this one, I have already made the video. How to select from the manual as well as software. So you have to select using software, Toshiba software. Based on this calculated load, you have to select this indoor unit. 510 is calculated, so I am going to select, for example, 5.5 tonnage, and is until here 5.5, and this is 2.5. Okay, and based on this air quantity, you have to 110 is equal to 400 CFM. Okay, I'm going to copy this, paste here. Okay, so number of unit is 1, 1 and 1. Kilowatt, convert into the kilowatt. Similarly, you have to apply the formula 110 is equal to 4.51 kilowatt, or you have to choose from the catalog 3.51 kilowatt. I'm going to copy this, paste here. So these are the selected, and this is the airflow, and total tonnage is nothing but the quantity into selected tonnage. For example, the same machine is 2 numbers, so you are going to put here 2, and model number you have to select from the catalog, and these are the, this is a split actually, the office 1, office 2, office 6. Office 6 is, if you check here, oh sorry, here is office 6 is your 510. You select here, check here, office 6 is 2.510. 2.510 I am going to use. So office 6 is here 510, load is 510. We check here, office 6 load is 510, so I am going to use the 2.5 tier each. 2.5 tier 1 number. Okay, so 2.5 tier 2 number. Okay, here is selected is 3. Okay, 2.5 tier 2 numbers. So these are the cassette, these are the duct table. Paste it here, and these are, first one is split, wall mounted split, and these are ductable, these are the cassette. And similarly you have to select the model number from the catalog, and here is your total tonnage, total selected tonnage. You see here, this is the total selected tonnage and this is in the HP. Okay, so simply multiply into 1.25, and these are the selected calculated load of outdoor unit. Based on this you have to select. For example, the selected is 45, so your diversity is 0.95, so this also you have to select outdoor unit from the catalog. Okay, actually in the load calculation this unit is thumbnail here, office X5 ton, so I used 2 ton. Okay, this is actually the calculated load, this is the selected load. So selected load is 33 ton. 33 ton is the selected load for indoor unit from the catalog, and the calculated load is 26.6. So 26.6 multiply this one into 1.25, you'll get 34 ton, 34 HP. So your machine will be of, after selection your machine will be 45 HP. So here you have to put the actual, here your outdoor unit is 45 HP. After selection, the selected unit 45 HP, 45 HP. Okay, this is the calculated. Actually 34 is calculated and selected is 45. 45 HP. Okay, so you have to prepare the similarly the summary sheet for each floor. This is the first floor I have prepared for you. Similarly, you have to select and prepare the equipment schedule for each floor. Second floor, third floor, fourth floor, and fifth and ground floor is only split AC. No need to select. Simply decide and place it. This selection is based on select from the manual catalog, available catalog. Okay. Now what we will do, simply copy this outdoor unit text as well and place it here, and down I'm going to place it here on the ground. Okay, copy these 4 numbers. Okay, now refrigerant piping, select these, and simply what you will do, simply okay, these are the first floor unit. Okay, and these are the second floor unit. This is for the second floor. This is for the second floor, and this is this unit for the third floor. This is for the third floor. Okay, and this for the fourth floor. Okay, and fifth floor is on the same place, on the roof only. I have put it here on the roof, and also you have to put FAHU. So what you will do, simply copy this FAHU. FAHU is 5 tons, so you can put on the roof, any floor also. So what you will do, you copy this and place it here. Move down each floor. First floor, how much is the cassette? Scale this one. No. Actually, for the cassette AC, how much? 3, 4, 5, 6. Check this one, how much? 1, 5 cassette and 2 split. So 2 split also. Okay, actually I put here 5 cassette. Move this one this side. Okay, move this, copy. Okay, move little bit. Okay, let's set up this move like this. Okay, so these are your units which flow. So what you will do, simply connect this. I'm going to connect this. Okay, similarly you have to copy this all, copy as well as piping, copy to each floor, copy to each floor up to fourth floor. To fourth floor. Now what you will do, extend this line. Okay, extend the boundary line, extend this one, extend boundary line, then extend this. Okay, so this is your riser diagram, and for the ground floor is the split and split here. And now what you will do, simply copy this FAHU from here. Simply this FAHU, so here. going to place this also on the ground floor. Here FHU, and then I'm going to do the piping. FHU fresh air piping. Simply select this, make it current layer, and now what I'm going to do, I'm going to do the to here. I'm going to change the layer current color, and here is your fourth floor is done. Then this floor, third floor done. Then fifth floor, second floor, then first floor is done. Okay, so this is your fresh air ducting. Okay, so I think you learn how to do the VRF project. So this is actually, here is we are doing as per same in the actual practice, but only the load calculation we are doing to use with HAP or E20 form. I will make separate video. I already made a video how to calculate the load using HAP or E20, but for the VRF I will make another video to calculate how to calculate the load for the VRF project. So this is your complete project, G+5 building, hotel project, office project, commercial office building, G+5 for VRF project. Okay, VRF, VRV, VRF is the same. So this is your complete project, G+5 floor commercial office building. Okay, VRV, VRF designing and drafting. So thank you for watching my video. Thank you. Bye bye. Once again, I would like to you guys, please do subscribe my channel if you are still not subscribed yet. So please do subscribing and hit the bell icon as well, so that you can get the notification of my upcoming videos, because I am making a lot of videos related to MEP services. So please subscribe and hit the bell icon, as well as you have to share my video with your friends circle, and please watch my full video so that you can get the full knowledge for designing as well as drafting. So thank you once again. Thank you for watching my